Okay, geometry students, let's go ahead and get started with hopefully our last review lesson here. We have a lot to do, so please take some really good notes and pay attention. Let's start off, please, with lesson 10.6. Lesson 10.6. Now, in this lesson, we'll be looking at three pretty tough to understand theorems. Okay, so take really good notes, and I'll try to explain this information well. Let's take a look at our first theorem. Now, you do not need to copy this down, although you're more than welcome to. Okay, that's fine. But it's theorem 10.13, and more important, know the theorem word perfect if you want to, but more important than knowing it word perfectly is, do you know what the theorem actually means? Okay, so here we go. If a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is half the measure of its intercepted arc. Okay? Now that's not really easy to understand. Let me try to explain that to you, okay? Look, here's a circle, more or less, okay? If a tangent in a chord, so a tangent is a line that intersects the circle at one place that you can take notes on this or just watch. Here's a tangent, okay? Here's a chord. Got it? Now, do you see this angle that goes from here to here? That angle right there. Okay? Well, that angle is going to be, look right here, half the measure of its intercepted arc. So, here's the angle. It goes from here to here. So what's the intercepted arc? Well, it goes from here to here. Okay, so this angle that runs from here to here, this whole angle right here, from this line to this line, is half of this arc right here. Now, the same is true for the other angle across. Over here, the angle that runs from this side here to this side here, this whole angle here, is going to be half the length of its intercepted arc. Well, that intercepted arc runs from there to there, right there, from there down to there. So whatever that arc is, whatever the measure is, that angle will be half of that. Okay? Now let's apply this to a problem. I would definitely copy this in your notes. Okay? Copy this down, please. Hold on one second. Okay, no, copy this down right here. Copy this down. Let me see if we can't answer these questions. So I'll pause a second while you copy this down and then copy these questions down. Just a couple seconds, though. We have to hurry. We have a lot to do today, okay? Okay, if you're not done copying, please continue to do so. But keep one ear up here while you're copying this information, while you're copying all of this down. If angle 1's 120 degrees, so this angle right here that goes from there to there, that whole angle's 120 degrees. What is the measure of arc A, B, C? So this angle here to here is 120 degrees. What is the measure of arc A all the way to B, all the way to C? Well, guys, look, if the angle's facing this way, which it is, then this is the intercepted arc from here to here, okay? Which it is. So this angle from here to here is 120. It's always going to be, now think of your theorem, the angle is always half as big as the intercepted arc. So if the angle is 120, multiply that by 2. The measure of the arc has to be 240 degrees, because half of that is 120. So this angle here is going to be half of this intercepted arc right here. Now on to question number 2. If arc AC is 160, so the arc from A to C, this arc right here, is 60 degrees. What is the measure of angle 2? Okay, fine. You're here's angle 2, here to here. So what is this angle that goes from one line to the other line, or from the chord to the tangent line? Well, remember, the angle formed is always half of its intercepted arc. So if the arc is 60, then the angle would be 30, half of the arc. Now, here's where it gets a little interesting. See if you can figure this one out, okay? If arc ABC is 220, so from A all the way to B, all the way to C, that arc ABC is 220 degrees, okay? Now if they ask for the measure, if I ask for the measure of angle 1, we'd cut that in half. Here's the measure of angle 1 right here. That'd be 110 degrees, correct? Sure it would be, but I'm not asking for the measure of angle 1. I'm asking for the measure of angle 2, which is right here. Okay? So what am I going to do? There's actually a couple ways to do this. Here's how we're going to do it. We're going to realize that the total distance around a circle when it comes to degrees is 360 degrees. So if from here to here is 220, then obviously from A to C, or C to A, this arc has to be how much? 140 degrees, because 220 plus 140 is 360. So if this arc from C to A is 140, then what is the measure of angle 2? Well, it would be half of the intercepted arc, so it would be 70 degrees. Okay, not too bad. Moving on to the next one. Theorem 1014. Now you do not need to copy this down unless you want to. If you want to, that's fine, but you don't have to. If two chords intersect in the interior of a circle, then the measure of each angle is half the sum of the measures of the intercepted arc by the angle and its vertical angle. Sounds like probably Greek to you guys. Let me show it to you like this. Excuse me. Now please watch. Please listen. Here is a chord, AC. Here is a chord, DB. Got it? The measure of this angle here, see how it's facing this way? The measure of this angle here is going to be, you would add this arc here, then go directly across to this arc. You would add those two arcs together and then divide by 2. Okay, that's it. If you want to find the measure of angle 1, then you would add these two arcs together and then divide by 2. Okay? Another way to put it is the measure of angle 1 equals, and then it would be AD plus BC divided by 2. Now, why am I writing it like a formula like that? Because sometimes you're going to be asked to find the angle. That's pretty easy. Sometimes you're going to be asked to find one of the arc measurements, okay? And that's going to be a little more difficult. But again, what this theorem is saying is this when two chords intersect inside, key word there, interior of the circle like this, then we have this angle here would be half of the sum of this arc and this arc. And by the way, that's also true for the other angle right here. Angle 2, the measure of angle 2 would be, you would take this arc here, the arc that's facing AB, then go straight across arc DC, add those two arcs together, divide by 2, and you would have the measure of angle 2. So with that in mind, please copy this down relatively quickly if you've not done that yet, and then go ahead and copy down these questions here, and we're going to answer those, okay? I'll give you just a couple seconds to do that. Just a couple more seconds, students. We have to move on. Okay, Okay, students, if you're still copying, that's fine. No big deal. Don't worry about it. But try to keep an eye up here as I move along here. Okay. Now, question number 1. If the measure of angle 1 is 40 degrees, so I'm going to go ahead and get rid of this number 1 for a second right here. I'm going to put 40 degrees right here. If this angle is 40 and the measure of arc AC is 35, what is the measure of arc BC? Now, let me think for a second. I'm pretty sure I meant to say arc AD, so in your notes, please change that to AD, okay? Arc AD is 35 degrees. What would this arc over here have to be? Now, there's 2 ways to do this. First of all, remember, if you add this arc plus this arc and divide it by 2, you get 40. So if your angle is 40, what you could do is take that angle in your head, multiply it by 2. That gives you 80, and then you know this arc plus this arc have to add up to 80. So you know the measure of this arc right over here would be 45 degrees, because 45, you could actually check your work, add 45 plus 35, you get 80, divided by 2 and you get 40, okay? Now another way to do it, if you didn't like that method, would be to write a formula, so you know you're going to say the measure of angle 1 equals AD plus BC divided by 2, okay? And then for angle 1 you put 40. For AD, you put 35. And now we're all set. We can solve the equation. This 2's in the denominator. I don't want that 2 there. I'm going to multiply both sides by 2. If I multiply 40 by 2, I get 80. If I multiply the right side by 2, like this, my 2 over 1. Sorry, that was pretty sloppy. 2 over 1. My 2's would cancel, leaving me with 35 plus BC. Then bring the 35 over, make it a negative 35, and you'll get the same answer, 45. Okay? Whichever works for you. But understand, you add these 2 arcs together, divide by 2, and you'll get this angle right here. Alright, now let's take a look at number question number 2. If the measure of arc AB is 100 and the measure of arc DC is 120, what is the measure of angle 1? Now, you might have read this and thought that I meant angle 2, but I really didn't, okay? Not at all, in fact. Now I know that this arc here and this arc here correspond with angle 2. I get that. But students, do I not have a straight line right here? Sure I do. Do I not have a line coming off it? Sure I do. So angle 2 and 1 have to add up to 180 degrees. Anytime you have a line with another line coming off it, this angle here and this angle here are always going to be supplementary. They have to add up to 180. Okay, so with that in mind, what I'm going to do is I'm going to find the measure of angle 2 and then find the measure of angle 1 is pretty easy. So here we go. How do I find the measure of angle 2? Well, I take this arc here, 100. This arc here, 120. Add them together. And then divide by 2. And I'll get 110 degrees. So this angle right here is 110. Now, if that angle is 110, and we know that angles 1 and 2 are supplementary, then angle 1 has to be 70, because 70 plus 110 is 180. So the answer would be 70 degrees. Okay, moving on now. This is the really pain in the neck theorem, because there's 3 parts to it, okay? And that's really going to be a pain, but we have to do it, so here we go. Now here's what it says. If a tangent and a secant gets one scenario, scenario number 1, or if I have 2 tangents, scenario number 2. Or if I have two secants, that's scenario number 3. And they intersect outside of a circle, exterior of a circle, then the measure of the angle formed is half the difference. Now back here, we were adding two arcs together and then dividing by 2. For this theorem here, the difference we're gonna subtract the two intercepted arcs and then divide by 2. Okay? So with that in mind, let's give this a shot and see how we do, okay? So like I said, this is scenario number 1. When you have a tangent and a secant, well, this is tangent right here. This is secant. So this would be scenario number 1 right here. Scenario number 2 is two tangents. Well, we have two tangents here. Intersects the circle in one place. Intersects the circle in one place. So this would be scenario number 2. Scenario number 3, two secants. Well, this is a secant. It intersects the circle in 2 places. This is a secant. It intersects the circle in 2 places. So this is scenario number 3. Okay? So when you have any of these 3 scenarios, the measure of the angle formed is half the difference of the measures of the intercepted arcs. Okay? So with that in mind, let's take a look at some problems. Alright, here we go. Please copy this in your notes. I'll give you just a second to do that. Please copy this in your notes. Okay, students, if you're not done, please continue to copy. Now, if arc AC is 56, so I'm going to highlight this in red and put 56 degrees. Arc, that should be arc right here, BCA is 200. So from B to C to A, alright? That whole arc is 200. What is the measure of angle 1? Now, first of all, let's think all of this through. First of all, notice, I'm going to go back here. Please notice carefully, students, that I have I might have lost some stuff. I hope that I did not. Yeah, I did. Okay, I'll have to redo that. Okay, anyways, look, students, notice I have a secant line and a tangent line. Now that's one of my scenarios given to me right back here. Secant, tangent. Alright, so I have that scenario. Now, please just dig deep and think. If AC is 56 degrees, okay, and then BCA from B all the way to C to all the way to here to A is 200, then how can I find just the measurement of arc BC? From B to C we'll take 200, which is the arc measurement from here all the way to A. Take 200 and subtract out 56 degrees. Alright, when you do that, you're going to be left with 144 degrees. So now I know the measure of arc BC. Now the measure of arc BC is 144. So here's my tangent line. Got it? Here's my secant line right here. Got it? Here's my tangent line right here. Okay, right here. These two lines are intercepting this arc here and this arc here. So what were we told to do in the theorem? You subtract these two arcs and divide by 2. So I have 144 minus 56 divided by 2. Alright? And we're going to get whatever that would be, 88, I believe. Yes, 88. So 144 minus 56 is 88. 88 divided by 2 is 40. and another tangent line, and they intersect outside of the circle. So here we go. If arc DE is 92, so from D to E is 92 degrees, what is the measure of angle 2? Now guys, look, it's common sense. We have to know the measure of DE, but we also have to know the measure of the bigger arc here too. Okay? Well, it's obvious. In a complete circle, it's 360 degrees. If from here to here is 92, then 360 minus 92 would give me the measure of this arc from D to E. So 360 minus 92, that'd be an 8 to 6, I believe. Yes. So this blue arc is 268 degrees. Now, how do I find the measure of angle 2? Well, this is the measure of angle 2 here. This is also the measure of angle 2 here because vertical angles are always congruent. So angle 2 here is the same as this angle here. How do I find this angle here? I subtract the two arcs and divide by 2. So I have 268 minus 92 divided by 2. Okay? And let's see what we get. I think 176 divided by 2. Let's see if that's right. Yes, that is correct. Okay, so 268 minus 92 is 176. Divided by 2 would be 88 degrees. Alright, okay, moving on to another scenario. And that scenario is, if angle 3 is 20 degrees, and arc FG is 100, what is the measure of arc AB? Now look, we have one of our scenarios. We have two secant lines. See that? Intersecting outside the circle, right here. So we have one of our three scenarios. So I know if I take this arc here, and this arc here, and I subtract them, and then divide by 2, I'll get the angle, which is 20 degrees. Now, there's more than one way to solve this problem. Here's one way. You know this arc here minus this arc here has to be twice as big as this angle. So if this angle is 20, multiply it by 2 and you get 40. You know when you subtract these two arcs, you should get 40. So this has to be 60 because 100 minus 60 is 40. That's one way to do it. That works. Another way is to make a formula like I've been teaching you guys. So I know if I take arc FG, this arc here, minus the smaller arc AB, I will then get, and divide it by 2, I will then get the measure of angle 3. Now, for FG right here, I'm going to put 100. Alright. For AB, I'm going to leave it AB. And for angle 3 right here, I'm going to go ahead and put 20 degrees because that's given to us right here. Now, let's solve this equation. This is another way to solve the problem. The denominator is 2, so multiply both sides by 2. If you multiply the left side by 2, or 2 over 1, the 2's cancel, leaving you with 100 minus AB. Over here on the right side, I have 20 degrees. I'm going to multiply this side by 2, multiply this side by 2, and I get 40. Okay, now we're almost done solving this. I would bring the 100 degrees over and make it negative 100, and that will leave us with negative AB equals negative 600, or negative 60, excuse me. Alright, now if really negative AB means there's a negative 1 there, so if I divide both sides by a negative 1, I would get AB equals 60, which is what we just got a second ago. Okay, so guys, I mean, these are pretty tough to understand if you're just reading the words, but if you're watching these examples, I hope they help a good deal. Alright, let's go ahead and continue on. Moving on now to our last lesson in this chapter. Now students, in lesson 10.7, we looked at equations of circular graphs. It was pretty simple and pretty easy, guys. It really was, okay? So, understand the principles I'm going to teach you now. Okay, now, I'll give you a second to do this. In your notes, copy down this circle, please. Now, when I say the circle is 2, -4, what I'm saying is this. And you don't have to draw all of this stuff that I'm putting on here. What I'm trying to show you is simply this. When I say the circle is negative or 2, -4, that just simply means that the center of the circle is at there. Not quite, sorry, but pretend it's over 2, my phone. Hopefully you get the idea. But, so, when I say the center of the circle is 2, -4, we're saying the circle, the center of the circle is over 2 and down 4 in a coordinate plane. Okay, that's all we're saying. Now, if I asked you to write the equation of this circle right here, it's so simple to do, guys. Remember, you put a parentheses and an x. Whatever this number is here, you change the sign. Then you put parentheses, then squared. Then you always put a plus sign, and then it's y. Whatever the sign of this number here is, you change it. Parentheses squared. Whatever the radius is, you always square it. That would be a sufficient answer. If you want to put 9, you can put 9. Either way is fine, okay? But anyways, that's the equation of the circle. It's so easy, students. Memorize this pattern, this formula, this model, and use that, okay? Pretty simple. Now, I might also ask you to graph a circle. So let me just go ahead and go like this. What if I gave you this equation? I said graph it. Alright, well, first of all, we know the center of the circle is what? Copy this down, please. The center of the circle would be, change the sign of 3. Change the sign of -1. -3, 1. Now the radius is going to be, please don't say 16. The radius is 4. Because I told you guys, the radius is always squared. So if I have 16 over here, I have to rewrite that with a power of 2. Well, 4 squared is the same thing as 16. So instead of putting 16, I'll put 4 squared. Now, the radius would then be 4. So now I'm ready to graph this thing. Actually, it should be really simple. The center is -3, +1. There we go. Now, if that's the center, in order to graph it, my radius is 4. Just go over 4 to the right from the center. 1, 2, 3, 4. Put a point there. Then go down 4. So start here. 1, 2, 3, 4. Then go to the left 4. 1, 2, 3, 4. Straight across. Then go up 4. So go straight up 4. Now, obviously that's not a perfect circle, and I'm fine with that, okay? But this would be a rough sketch of the circle of this equation right here, okay? Alright, so there we go. Pretty simple, not too bad. Now, we're going to go through chapter 11 pretty quickly, guys, okay? In lesson 11.1, on April 6th, we studied the perimeter and area of squares and rectangles. Now, guys, come on. You can copy this down, just watch. Here's a square, side of 4. What would the area be? Well, 4 times 4 is 16. What would the perimeter be? It would be 16 also, actually, because 4 plus 4 plus 4 plus 4 gives you 16. If I have a rectangle, measurements of a 3 by 7 rectangle, well, the area would be what? 3 times 7, 21, and the perimeter would be 20. 3 plus 7 plus 3 plus 7. Now, if you need to take notes on that, feel free to. And don't be embarrassed of that. However, I'm telling you now, this is not too difficult, okay? So the perimeter area of squares and rectangles, pretty simple. Lesson 11.2, April 7th. In this lesson, we learned how to find the area of parallelograms and triangles. The area of the parallelograms and triangles. Now, by the way, on your exam on tomorrow, you're welcome to have a little formula sheet with these formulas on. I don't think you'll probably need formulas for this, but if you do, that's fine. You can write those down. But the formula for the area of a parallelogram is base times height. The area of a triangle, the formula is 1/2 base times height, okay? So with those two formulas in mind, first of all, you can write them down, and you can have those for the test on tomorrow, okay? That's fine. Now, how do I find the area of a parallelogram? Well, let's say this is 4. We'll say this is 9. This is not the height of the parallelogram. That is not the height. The height is the vertical line that connects the two parallel sides, okay? Like that. So in order to find the area of this parallelogram, you would have to be given the height. Actually, you could use sine, cosine, or tangent to find the height. I'm just going to go ahead and give it, we have the angle right here. And then you could use sine, cosine, or tangent to find the height. I'm going to give it to you. In this case, the height would be, we'll say 3, okay? So, how do I find the area of this parallelogram? Base times height. Is that so easy? If this is 9 right here, then we know opposite sides on parallelograms are congruent. So this side here would also have a length of 9. So my base would be 9. My height would be 3. So the area of the parallelogram is 27. It's that simple. Base times height. Base times height. Pretty simple. Now, let's find the area of a triangle real quick just to practice. Alright, now, look. We're going to find the area of this triangle, okay? In order to do that, I have to know the base and the height. Now the base is 5. The height has not been given to me, so I'm going to call it 2, okay? So there we go. 1/2 times the base times the height. Pretty simple. 1/2 times the base times the height, okay? Which would give you 5 units for the area of this triangle, okay? So feel free to write down these two formulas. Well, one's gone. Feel free to write down these two formulas on your exam cheat sheet, okay? No problem with that. Alright, moving on to 11.3, April 8th. Now in this lesson, we learned how to find the area of trapezoids, rhombi, and kites, okay? So, with that in mind, let me give you some formulas. The area of a trapezoid, the formula is 1/2 times the height, and then we add the two bases together, okay? Now, let me jump ahead to these two formulas here. Rhombi and kites have one thing in common. Are you ready? Their diagonals are perpendicular. Now, why is that important? Well, I'm glad you asked. Here's why it's important. Anytime a quadrilateral has diagonals that are perpendicular, anytime a quadrilateral, that's a four-sided figure, has diagonals that are perpendicular, you can use this one formula for all of those types of figures. It's 1/2 times diagonal times the other diagonal. Okay, so again, this only works on quadrilaterals whose diagonals are perpendicular, but anytime you have a quadrilateral with perpendicular diagonals, then you can use this formula for sure. Okay, so use it for sure. So I'm not going to get into a lot of examples here for a trapezoid like this. We'll call this 5, we'll call this 6, we'll call this 7, and we'll call this 4. Now, this is not the height of a trapezoid. This would be the height right here. Okay, and by the way, no matter which way I turn this thing, the bases are always the parallel sides. So even if I grabbed this thing and turned it this direction here, so it looked like this would not become a base right here. The parallel sides are always the bases in a trapezoid, okay? Now, same thing for a kite. To run by in kites, both have perpendicular diagonals, so you can use this formula right here, whether it be on diagonals or whether it be on, rhombi or kites, okay? This formula will work on those, both of those. Alright, now let's continue on. And by the way, I guess I better go back. I better at least fill in the numbers here. So if I asked you to find the area of this trapezoid here, it'd be 1/2 times the height is 4. Put a right angle here, the height is 4. And then B1 plus B2, I would just put 13. So the answer would be 26. Okay? I think, is that right? Let's see here, 2. Yes, 26. So, just make sure you have these formulas written down on a sheet of paper so you're ready for your exam. And make sure you have like area of trapezoid equals, and then this right here. Alright? So, moving on. Rhombi and kites have diagonals are perpendicular, so use this formula here. Alright, let's see 11.4. In this lesson here, we learned how to find the area of regular polygons. Now the formula for the area of a regular polygon is simply this. Are you ready? 1/2 little a capital P. Now little a stands for the apothem or the apothem. Okay, I've heard it pronounced both ways. P stands for the perimeter. Alright, so please don't forget that. P stands for the perimeter of the object of the regular polygon, and A is the apothem. Now, in case you've forgotten what the apothem is, let me refresh your memory. You need to know this, okay? Let's say I asked you to find the area of this hexagon. Wow. Okay, there we go. Now, remember it's supposed to be a regular polygon, which means all of these sides would be congruent. Okay, all of these sides would be congruent, even though my drawing looks pretty bad and it doesn't look like it. All of the sides would be congruent. Now the apothem is always the length from the center of the regular polygon to the midpoint and perpendicular line drawn to one of the sides. So the apothem is always the length of the line that starts in the middle and hits a side, but it has to be in the middle, so this segment's congruent to this segment here is congruent to this segment here, so it always has to hit the middle. And secondly, it has to be perpendicular. Okay, so that's what the apothem is. So know how to find that. Okay, in the perimeter, if one of these sides was a 5, well, the perimeter would be 30, right? 5 plus 5 plus 5 plus 5 plus 5 plus 5, which is 30. Okay, so in order to find the area of a regular polygon, it is 1/2 times the apothem times the perimeter. And so you would find this length right here, we'll call it A, and then put in, of course, your perimeter here, all of that times 1/2. And not too bad to find the area of this. Okay, pretty simple. So make sure you know this. Make sure you have this written down. Alright, moving on to 11.5. In this lesson, we learned how to find the circumference of a circle and the lengths of arcs. Now, the formula for circumference of a circle is simply pi d. Pretty simple. Pi times d. Okay? Now, interesting to me. I don't think it's very difficult. What if I had this angle here and I called it, I don't know, 115 degrees, okay? And then I asked you to find the length, not the degree, because the degree measure of this would be 115 degrees, okay? Because if a central angle is 115, then the arc would also be 115. But I'm asking you to find the length of this arc. In other words, if I could grab this arc right here and stretch it out in a straight line, then I would have the length of this arc right here. So this is really not too difficult to do, students. If I know the entire circumference around this circle is 31.4, and I do, that's what you would get. The entire circumference around this circle is 31.4. I use this formula here to get that. Now, how would I find the length of this arc right here? Well, you simply find out, listen guys, what fraction of the entire circle is this arc? Is that arc half the circle, a quarter of the circle, 1/3 of the circle? And we do that by taking 115 and putting it over the total degrees in a circle from here all the way around, which is 360, okay? Now, students, if that part confuses you, it's really not that difficult. You're just taking the actual angle and putting it over the total. Look, if there were, I don't know, 12 males in a class and 9 females, and I said what fraction of the class is the males, you would put 12 over 21, because 12 out of 21 are males. I got 21 from adding these two together, and I got 12 because 12 is the males. So same thing over here. If I'm trying to find what fraction this arc is, I take 115 and put it over the total, which is 360, and then multiply these two together, and you'll have the length of that arc. So here we go, 31.4, I'm doing it real quick here, 31.4 times 115 over 360, and I'm getting 10.03. So I'm going to say the arc length of this arc is 10, not 10 degrees. Okay, I don't want the measurement of this arc, I want the length of it, and the length of this arc would be 10. Alright, we'll go ahead and put a mark here for feet and a mark here for feet, so we'll call it 10 feet. Okay, alright, moving on to lesson 11.6. It's the last one. We got about 3 minutes to cover it, so here we go. How do you find the area of a circle? Pi r squared. Got it? Okay. Now, here's a circle. Let's say I have a sector here that's, I don't know, 30 degrees. That's not 30. It's more like 45 degrees. And let's say the radius is 2. Alright? Now, we'll say 2 inches. Now, first of all, I want you to find the area of this circle. Okay? So, to find the area of this circle would be pi r squared. So, pi times 4, because if you square the radius, you get 4. So, 3.14 times 4. The entire area is, the area of the circle is 12.56. Now, what if I asked you to find the area of just this sliver right here? What if I asked you to find that area? Well, think about it, guys. Come on. I could find the entire area of this whole circle, which I did right here, and then find out what fraction of the entire circle this area is. Well, I had 45 degrees written right here. So how would I find out the fractional part of this shaded area here when it compared to the entire circle? I would simply put 45 degrees over 360. That's a fractional representation of this area right here. Now, you would take the entire area of the entire circle times this fractional part, and you will get the correct answer. Let me quickly grab my calculator and do this. Just to give you guys a little closure and a little of answers. 1.57. So the area of the shaded sector right here is 1.57. Okay, so a couple things to learn there. Make sure you go over this math well, students. I hope everything is going well for you guys. If you have any questions, hopefully this video has been helpful to you guys. If you have any questions, don't hesitate to call or email.